Okay. So, good morning. I'm Alessio Gauzolino. I live here in Milan, and I have a bachelor degrees in product design, and now I have a master degree in the course masters. And so, I during the in the project, I develop the design part and also assembly all the components and make the test for the behaviors and the components, electronic components, where they were assembled on the robot. Ali?
Okay.
Ali?
Okay. Hi, my name is Ali Emre. I'm from Turkey, and my bachelor is in computer engineering. I finished that in Turkey. I worked for 2 years in the industry, and then I moved to Italy, Milano, to study computer science and engineering masters in Polimi. I'm currently in Milano. In the whole project, I was living in here. And my main work in this project was to create the behaviors, the coding the behaviors, and also creating a mobile application for the image processing. And in the end, I met with my colleague Alessio to construct a robot, put everything together, and test all the behaviors that we have created for this competition.
Amir?
Hi, my name is Amir Rafiee Samani, and I'm from Iran, and now I'm staying in Iran due to the coronavirus situation. I'm a student of Master of Science in Mechanical Engineering at Politecnico di Milano, and my bachelor was in Mechatronics Engineering field. In this project, I calculated the data to select the motor behaviors and the materials and the structure we need, and I talked with the designer of the group to help him to design the mechanisms of the ears and legs of the robot. And also I talked with the coder and help him to test all the components, and I designed a PCB and test when it arrives in Milan, and starting to test the robot together.
Thank you. Microfono.
The microphone is off. Okay.
Okay, sorry. I am Mattia Sanchioni, and I am from Italy. I'm a master degree student in computer science engineering, and I studied automation engineering during my bachelor degree in Milan. For this project, I took care of the integration between the hardware and the software working from Rome. And I both tested all the electronic components and the sensor, and wrote the skeleton of the function that I've used in the final code when the robot was assembled in Milan.
Thank you.
Thank you.
Okay, good morning, everyone. I'm Tim, and I'm from Germany and currently also in Germany. I have a bachelor's in graphic design, and now I'm studying communication design. So my main responsibilities in this project were the design research in the beginning of the project, then the project documentation through the report, and doing all the illustration and graphics that you saw over the presentations and in the report. So today we are going to start with the design research, what we did in the very beginning. And for that, we defined 5 criteria that we wanted to closer investigate. That was the appearance of animals, the strategies, the application of how we could apply like animals to our project, and then the strengths and weaknesses these animals have. So in order to do that, we set up a spreadsheet on Google and did a little like brainstorming for that, and just put in like ideas and research that we could find through like reading, through videos, through other projects, what we could apply to our animals. And there was not really a direction yet. We just made a list of what is possible. Then we choose 2 animals. In this case, it was the octopus and the crocodile. We went further and combined also an octopus and a hippo, or an octopus and an elephant. But like these like very early ideas were not very satisfying to us. The problem was that we focused too much on only the appearance of the animals and their very obvious characteristics. We didn't like find anything to distinguish them enough, to have a big enough contrast. And that's why we went back and thought again on what animals we could combine. And the final solution was combining a crab and an elephant. because in our opinion, they have like a big enough contrast in terms of strategies and behaviors that we could use like in a helpful way in our robot. For example, the elephant is more like a strong and smart animal. It's very heavy, and for our research, we learned it's also emotional, which was important to us. On the other side, the crab is very flexible in its movement. It can move sideways and forward. It's very fast compared to its size. It has a very protective behavior about its territory, which was important for us, and can be very aggressive, which could be helpful for our attacking. That's what we thought. So we combined the elephant and the crab, and the outcome was the Elecrab T-100, our robot. And now Ali will continue to explain the strategy and the behavior.
Okay, so when we designed the behaviors of our robot, we split the things that we have to do to 4 sections. And now I will go into detail in one at a time. So first, the robot should be able to find the pond and to be able to go to the pond. And from the competition, the most amount of points we can gain is to be staying in the pond as much as possible. And the next one is to we should be able to understand if we're drinking and to be able to move at the same time if we're being attacked. So we make it hard for the other enemies to attack us at the same time. And the other one is we should be able to avoid the enemies, where we can detect with the sensors where the enemies are coming from and should be able to run away from them or attack them whenever it's needed. And the next one is to protect the territory. So when enemies are coming close to us, we should protect some area around us to keep us safe as much as possible. So to be able to accomplish this, we decided to use a fuzzy logic controller, that is a higher level controller, which decides the behaviors depending on all the inputs that we give to the system. And I will not go into detail to each of the flowcharts, but I wanted to focus on 2 of them. That's the most important in our opinion. First one is the going to pond. So when we have the pond in our sight, we should be able to move towards it and also evade all the obstacle that is on the way. It can be enemies or other obstacles. And the next one is to drink and defense. We think this is also really important. When we are drinking, the enemies can come close to us and attack us at the same time. So we should be able to do a fast rotation when we're being attacked or move away from the enemies. That's what we have thought. And for going into more detail about the fuzzy logic, we have 4 fuzzy logic inputs. The first 2 are is drinking and is attacking, which is just Boolean, very simple values. And the third one is being attacked, also a Boolean value. And we also have a pond distance. This one is where we can understand the pond is close, in a medium, far, or unknown distance. And unknown distance is that we don't know where the pond is or it's too far away. And we decide our behaviors depending on this inputs. We have 2 fuzzy logic outputs. That is, the first one is the behavior decision. We have 5 behaviors to choose from. And we also have a movement speed as an output, which is used when we select it for each behavior. For our robot to understand where the pond and the target is, we created Android application. We used OpenCV for the image processing, and we were able to reach 60 frames per second while understanding pond and the target at the same time. We have also used Bluetooth low energy communication to send this information from the smartphone to the boards so the whole logic can be run. And also from the boards to the smartphone, we have also sent back some communication to play some audio effects to give feedback about the robot, the behavior and the feelings of the robot. And now my colleague Amir is going to explain more about the electronics.
Thank you. At the first stage, we started to predict the weight of the robot from the data of the components which we found on the internet and the first sketch of the robot in the 3D modeling application by Katia. Then I made a simple calculation about the velocity that we need for the robot and also momentum, which applied on the tasks in the competition. And then I started search and select the motors and the batteries, which have enough power for our strategies. Next page. I started to talk a lot with the designer of the group and together find some solutions to reduce the weight of the robot in 3D printing pieces, tasks, walls, and sensor holders. And for the safety of the motors, I used the safety factor of more or less 1.5. But at the end of the making robot, when the materials assembled, the weight was less than what we expected. Next page. We choose ESP32 and Blue Pill microprocessor. At first stage, we need many pins because we have a lot of sensors and we have a lot of calculations about fuzzy logic and image processing. We choose ESP32 because we need a Bluetooth connection of ESP32. And in this project, we have an image processing to find the pond and enemy target on the smartphone. Then we send the data to the ESP through the Bluetooth connection to analyze and send the data for the calculation of behavior and movement. Next page. We choose Blue Pill because the frequency which it works with is high and also it's cheap solution with great processing capabilities. And because it uses ARM-based microprocessor. Next page. Then due to the limitation of the time, I started to design the PCB with Altium Designer application before the electronic staffs arrived. And after they arrived, I talked a lot with the coder Mattia, and we started to test all the components together. And after we made a PCB, we understood some pins of STM32 and ESP32 doesn't work properly if we connect the pins on the PCB. Then for fixing this issue, I soldered some wires on the back of one of the PCBs. But because it wasn't stable and neat, we decided to make another PCB. Next page. Starting to test remotely, and then I sent the components to the Milan from Iran, and we starting to test all the electronic steps with PCBs. Now, my colleague is going to talk about the sensors. Thank you.
These are the sensors used in our robot, and now I start to describe them one at a time. First of all, the robot uses 6 ultrasonic sensors to detect the obstacle around it, and also used to avoid the walls and find enemies, both to attack and defense. They are arranged all around the robot with a more density in the back, since the head is more protected thanks to the ears. Then the color sensors helps the image analysis to detect when the robot is drinking and when is attacking. And one sensor is in the bottom of the trunk, and the other one is in between the task in order to detect when we are attacking the enemy's target. Then we decided to use 2 LED matrices to emulate the eyes, on which several emotions are shown depending on the state of the robot, of the behaviors. And moreover, the matrices at the end of the challenge can also show the final score. We decided to reproduce the previous one, please. We decided to reproduce this for emotion, so the attacking, the defending, the drinking, and the anormal looking, a default one. Then we, in addition to the LED matrices, we emulate the motion also with the movement of the ears, thanks to 2 servo motors. For example, when we are attacked, we open the ears, and in order to cover as much as possible our target. Or for example, when we earn points due to the drinking or the attacking, the ears vibrate in order to show an happy emotion. Then the communication used in our robot are the I2C communication and the BLE. The I2C communication is organized in master and slave and connect all the freeboard. And the ESP32 has to be the master. For these reasons, we put the logic inside this board, and it collects all the data from the sensor mounted on the other 2 blue pills, and it sends back the output of the fuzzy logic to the slaves. More precisely, it sends the movement to apply to the motors to the probe that control them. Finally, the BLA communication is possible thanks to the ESP32 that has both Bluetooth and the wireless. The application on the smartphone send the output of the image analysis on one characteristics that can be read from the ESP32, and it can reply on a different characteristics if it is necessary. And it sends the sound to reproduce that helps the eyes and the ears to show emotion in a more effectiveness way. Now I give the floor to Alessio.
So our project started with this cardboard model to understand the volume and the dimension of our robot. And then the process, it's quite interesting because we analyze different kind of materials, passing to heavy robot made by metals and 3D printed stuff. And now we have another kind of robot that use PLA and cork in order to simulate better the two animals that we decide to represent. So this is the step, the previous step with the metal and the PLA. And now we talk about the structure of the robot. So the robot is made with a made structure in plywood, and then some components 3D printed that with a good tolerance, with a small tolerance in order to use less screw as possible, because for the thickness of the plywood that is only 4 millimeters, it's better to don't use a lot of screw. Then to place the PCB, we use the Forex because there is a materials that can adapt easily to the shapes of the PCB and also to the pin that are on the back part of the PCBs. Then to the main structure, we add the components 3D printed to recreate the shell of the crab. So we can see as the legs around the back part of the shell can be placed. And then we have the head structure that is the place where we put the ducts, the LED matrix, the servo motors, and where we place also the smartphone to see the pond and reach our objectives. So this is the final shape of the robot with the cork parts that that represent the elephant body and the skin, while the 3D printed elements represent the crab parts of the robot. So now we talk about the construction of the robot. So while Mattia was working on the components at Rome, he reproduced the base of the robot in order to place in the correct position the ultrasonic sensor, and then he sent to me the components, and I added the components on the structure. So these are an example of the process of 3D printed for the shell of the robot that takes more than 2 days to print it, and also a lot of work and hour to design better how to produce this kind of part of the robot. And then we place also the PCB that Amir sent on the from Iran. So we make all the tests for the single components and understand how the components have to be positioned on the PCB with the cables. So this is an images of me and Lee that are working while Amir and Mattia was connected through Teams in order to suggest us how to proceed. And this is the phase of development of the construction of the robot. And then we have a video that show the behaviors of the robot. So for the first one, we can see how the robot go to the pond. So we activate it and we recognize the pond and go there, and then start to drink with the emotion of the eyes and also the sound. Then there is a defense. So where the target is attacked, immediately the robot start to defense. And then there is also the attacking phase. So how the robot approach the enemy's target with the show of the emotions, and we can see how the robot go always nearer to the target. And then we have some example of the phase of development and trials that we have to do with the robot, that we call structure test, because we understand how it was durable and resistance to all the times he go through the walls and everything all around. So thank you, and this is our robot.
Then thank you very much for the presentation. It is very interesting. We are curious to see how it works, and congratulations, because it seems to be very, very interesting and very fine. Well done.
Well done.
Then thank you very much.